Okay, we are continuing on with our little review of items in this booklet. Each student in my Math 100 class has one of these little booklets, so yours is a little smaller. But again, the answers are at the back of Chapter 1. Once you go through all the sections, you do get to the answers. So the first four are definitions, and again, look at those. And if you're not sure of the answer, you can check, but you ought to be able to do those. So we're going to focus on some of the operations with real numbers, and one of them is absolute value. And once again, absolute value relates to where on the number line, how far is a number from 0? So how far is -2 from 0? And we just count. So it's 2 units. How far is 2 from 0? And you just count. It's 2 units. So we say the distance by counting that something is from 0, that is its absolute value. And we use the vertical lines to either side of a number to indicate they're asking you to find absolute value. So the absolute value of any number is its positive value. And 0 is neither negative nor positive, so it's 0. And here this would be 2 1/3. So this is, as long as you understand what's going on, you know the symbol. Now the trick that happens every once in a while is if they put a negative outside of the absolute value sign. Now it comes out of the absolute value as 9.5, but now you apply the negative sign. So if there's a negative sign, whatever comes out of there, which would be positive, then you apply that negative sign. All right, in this next part, they're asking us to determine if the order of numbers, as is listed here in these inequalities, whether they're true or not. And the key, if you're ever wondering, again, is the number line. Anything to the left of something on the number line would be less. Anything to the right of something on the number line would be positive. So here we're saying -7 is less than or equal to -11. So where is -11? Well, -11 is over here, and -7 is over there in relation. So is -7 less? And the answer is no. -7 is actually greater. So to make that true, it's false as it is, to make it true, it would have to be this way. -3 is greater than -10. Again, -10 is over here somewhere, and -3 is to the right of it. So this is true. All right, continuing with operations of real numbers. And you might say, what are the operations? Well, it's addition, subtraction, multiply, divide, squaring, square root, absolute value. Those are all operations. And there's some basic rules, and in class we go over this in some detail, but as a quick review, when you have something that's a negative number and something that's a positive number, they say, what's the absolute value of 15? Well, it's 15. What's the absolute value of 6? It's 6. Well, subtract the smaller absolute value, which is 6, from 15. And that's going to give you 9. But now what you have to do is apply the sign. In this case, it's a negative sign to your answer, and you get your negative 9. So once again, you take the larger absolute value, smaller absolute value, subtract the smaller from the larger, and then use the sign of the larger absolute value. Now, if you're using your calculator, you could just go 6 minus 15 and get negative 9. Now, here we see this is an addition, but we're adding two negative numbers. So if we're adding numbers who have the same sign, the answer is the negative. And then you just add these together, and that's going to be 6.9. Now, in this case, they're asking you to, in this add, unlike signs of fractions, or in a sense, subtract this fraction. And in order to do things with fractions, we must first have a common denominator, which in this case, if you're not sure, you can just multiply your denominators and get 15. And what did I have to multiply the 3 by to get it to be 15? Well, a 5. And in order to keep the fraction equivalent, I have to multiply the numerator by 5. Remember, 5 over 5 is 1, and you can multiply anything by 1, but to make equivalent fractions, we have it, the 1 in the form of what we want to get. In this case, it's 15. So it has to be 5 over 5. So this becomes then a 10. Keep in mind there's a negative sign there. We have to multiply this by a 3. So that's going to be a 9. And then once we develop a pattern, and this may be something that you are weak on, so you have to work on this, this is going to become a 1 over 15. Now in number 14, we see here we have a positive sign of a number, and it's the same number with its opposite sign. So these we say are the additive inverse, or the opposites. When we add opposites, our results are always a 0. So I've skipped a few. I think those are pretty easy. The opposite of something is just its opposite sign. So here they're saying, find what the opposite of x is. So what is the opposite of this? The opposite of that is 15. What is the opposite of this? Well, it's a negative 5/8. And now, as we look at these, we see they are, instead of adding as we did before, they're subtracting. So again, we're going to use the rule. The larger absolute value is 12. Smaller is 3. 3 from 12 is 9. And we're going to use the sign of the larger absolute value. Again, if you put this in your calculator, it comes out that. In number 20, a little tricky, we went over this in class. When you see a negative sign in front of a parenthesis, and that happens to be negative, what they're actually saying, the opposite of a negative 9. So the key to this, as you write it, you can actually just change the signs, and this is going to become a 7. So here in 21, we see the same thing. The opposite of something makes this a positive. So 7 and 5 are 12, carry 1, 3.2. No, maybe how about 4.2 there? 3 and 1, carry 1, 4.2. Okay, we're now moving into another operation. In this case, it's multiplication. And in class, we gave you this little rule that if the signs are like, the results of multiplication would be positive. Unlike, it will be negative. So if one is positive, one is negative, the product then is negative. If they're both negative or both positive, the results are positive. So one of the little techniques I tell students is, what will this end sign be? If you figure that out, then you don't have to worry about the sign. So here, this is going to be positive. This one is going to be negative. Negative times negative, this one will be positive. Now this is negative times negative, so the results of this will be positive. So we've determined what the sign is. Now it's just a matter of multiplying. 3 times 8, 24. Now multiplying anything by 10, the quick way to do it is just move the decimal place one place to the right. So negative 56. Again, multiplying anything by 1, it stays the same, but here we've determined the sign is going to become positive, so 1.8. And here, this is interesting because they happen to be something we're going to talk about here very shortly, reciprocal. They are reciprocals of each other, and when you multiply reciprocals or fractions, you want to cancel out wherever you can, and you just get ones all over the place. So this just becomes a positive 1. Now, what is a reciprocal? Well, again, by definition up here, if you multiply a number by its reciprocal, the results are always a positive 1. But how do you figure it out? Well, any number is over 1. So to find a reciprocal, you use the same sign and just flip it. 1 over 12. And notice now, negative times negative makes it a positive. And we don't write the positive usually. And then everything just cancels out, and you get up with 1. Again, it has to be the same sign. So negative, just flip it over. And everything cancels out, and you just get ones all over. And that's that. All right, fortunately, when we divide, the same rules apply. If they are like signs, the results are positive. If they are unlike signs, the results are negative. So again, determine what will be your end sign. Then you don't have to worry about the sign. So this is going to be a negative. This one will be a positive. Again, if it's positive, we don't write it, but it's good that we're using this technique. Positive and a negative, so our results will be a negative. And this is a negative and a negative, so our results will be a positive. Now, here you're dividing, and again, you can use your calculator for this in some cases. 12 goes into 36 3 times, so negative 3. 20 goes into 40 twice, so positive 2. And division of fractions. For those of you that aren't familiar with it, listen carefully because this is how we do it. we always change division of fractions to a multiplication problem. So I'm changing that from division to multiplication. This first item stays the same. This second item, in a division of fractions, we change it to its reciprocal, which is going to be 4 over 1. But notice, we changed the division sign, and we took the reciprocal. Now remember, we determine what the sign is going to be. Otherwise, this happens to be a negative 4 over 1. Now here we can cross cancel. 4 goes into there once. 4 goes into there twice. And our answer becomes a negative 3 over 2. So we multiply now our numerator and our denominator, and we get that. And again, we said we could put the negative sign up there, down there, or the preferred place is next to the division bar. And this one, the same. So we know it's going to be a positive, so forget about the sign. 5/12 times, changing that to multiplication. Now keep in mind, a number is always over 1. This becomes 1 over 10. Now here we can do some cross canceling. 5 goes into there twice. 5 goes into there once. So we get that as an answer, a positive 1/24. And I just want to once again comment about our booklets. This one, it's bigger, but if you go to the end of chapter 1's material, this is what the answers look like. They're just the answers where you can check to see if you are mastering the skills. You need to do practice and quiz me's. That's where you get points. But this helps practice to give you a visual thing. And keep in mind, there are extra pages here where you can actually show some of the work. And if there's anything you don't know how to do in this booklet or in Math Lab, as you're doing the practices and things, write the example out. Sometimes you can ask me. But on the 5th floor of the library is the Learning Center, where there are tutors. And hopefully we're going to have a specifically set up for math students in Dana Hall, room 130, a room filled with computers with tutors that on a Friday you can come in to get help. It's not going to start the first week of classes, but should be in operation after the second week. And I will give you more information on that. And have a great day, and good luck with all your math work.